Ready to start. So let me share my screen. Okay, so this week we have a special Gardener review meeting because the hackathon took place last week. So as usual, we use this occurrence for a short wrap-up for all the topics that have been hacked on, or at least all the topics that also can present some results. As usual, there is here on the left side in the hackathon section also a page dedicated for this occurrence. And you see also all the topics here. In the course of the week, we will also add the respective topic summaries, but you can also click to the respective issues if you are curious and want to find out more. Generally, yeah, this was the team. As you can see, we were again at the same location in the Schlosshof in Schelklingen, near Ulm in Germany. And yeah, I think we had around 20 people this time. So yeah, as usual, it was a lot of fun. And also, as you can see, we have made quite good progress and had a lot of variety of topics. Also new this time was that we used this Gardener Hackathon repository for the issues and the topic proposals and also the votings. So you can see here the list of the votes and the initial team members assigned to it. And you can also see if you scroll down that there were a lot of more ideas, but yeah, there was just not enough time or enough people to work on them. So there's plenty of more backlog for upcoming hackathons. All right, so then I will not go over the agenda this time because it's too long. As usual, every topic is limited to 5 minutes. So we should maybe take, I don't know, a bit more over an hour for this meeting. And yeah, as usual, we probably should refrain from questions during the meeting to not prolong it even more. So if you have questions, please write them to the chat. The presenters can ask later or just use the Slack as usual. Okay, then I would say we get started. Toby, please present the ManagedSeedSet topic.
So yes, at first, Tim, me, and Victor worked on completing the ManagedSeedSet implementation, and yeah, we did a prototype, but actually working. But after the first day and more discussions, we actually turned on to the complete opposite and proposed to removing the implementation for several reasons. And yeah, because we found out that keeping the configurations of all these managed seeds within the set in sync or homogeneous through the whole set is quite difficult, as the logic of the GardenNet itself is already quite sophisticated in for example managed seeds inheriting some kind of configuration from its parent GardenNet by default. So it depends on where the managed seed on which seed gets scheduled, what kind of configuration it gets. So yeah, this could be configured so everything is just on one seed, but it's also a bit of a hassle and something that's not really great. Also stuff like versions, they also get propagated through the parent GardenNet. So yeah, which makes the whole idea maybe a bit less powerful, so to say. The other main benefit that we saw within the managed seed sets was the auto scaling, and I think a lot of people also thought about that. But after also thinking about this, we decided, or we came up with it, that adding or removing seeds is for everyone we talk to either infrequent or easily to do manually today, and with just creating another managed seed. And in production landscapes, for example, you usually also don't want seeds to be autoscaled because you don't have the overview. Then, for example, if you do GitOps, how many seeds there are actually there, then you would need to set up alerting and stuff like that, and to avoid unexpected scaling. There was also a feature about feature rollout, like staging a feature rollout, like it's possible with stateful sets today with the partition feature. But this also proved some difficulties, which basically led us for the decision that as currently the implementation is not mature enough as of today. We decided that the effort in completing the implementation and also the ongoing effort of maintaining this is probably not worth it. Therefore, we proposed with dropping it all along. Yeah, if you have anything against that or strong opinions against that, please let us know. If you have other arguments against that, then we can talk about this. But if there are no strong opinions against removing it, we would go ahead and remove the API in some future releases. That's about it. Thank you very much.
Yeah, thanks, Toby. Then next up is Jeff with improving debugability of failed node joins.
Yeah. Good morning, everyone. So let me haven't worked with Teams in a while. Okay. All right. So basically, Valentin, Konstantinos, and I worked for the first part of the hackathon on a little bit more of a verbose output during the node deployment or during a shoot deployment. Basically, when the Gardener node agent boots up or gets bootstrapped, there's a certain time period where it can fail, mostly due to connection issues. And this is really hard for an operator to debug or to actually get an idea what actually is wrong with the shoot. And our mission was to get somewhat of a log or a statement out to the serial console so that an operator on OpenStack or wherever can actually see what is happening with the node. More specifically for customers who actually have to lock down their nodes, basically have no auto-logon enabled or have otherwise no capabilities of accessing the node to get a clear log view. So the issue actually was pretty straightforward. The only trouble we were running into is that our current setup is actually stating that everything from every binary we deploy is actually currently logging to standard error. So we had to some sort of separate those logs who has to go to the serial console because we want to hold it as clear as possible, don't overwhelm or don't overexpose logs to the serial console because it gets quite messy without any issue. So if we would have just said that everything console, this would give us a messy serial console and no one would actually win anything with that. So what we have actually done is fatal errors during the startup procedure of the of those two binaries for bootstrapping the node actually logged to standard out so that we were capable to pin the standard output for this systemd unit to journal and console. Then we actually implemented another suggested test for the connectivity part to get an actual verbose output if the connectivity is actually at fault. And that's basically it. So pretty straightforward. already merged, as you can see. So the most hassle we actually had were to get through our flaky state and through the E2E tests in our pipeline. But that's basically it. So I can keep it a bit shorter to get more time to other people. Thank you.
Awesome. Thanks, Jeff, for presenting. Then over to Lucas for adding support for the virtual garden to the ACL extension.
Thanks, Raphael. So I hope people can hear me. I think so. So the idea of this topic was that there is currently no place or no way in Gardener to lock down the access to the virtual garden API server. So, for example, some landscapes might want to don't expose the API server publicly, but rather have it only available in a certain network or through, for example, a VPN. So this was the idea to reuse the ACL extension, as this is already usable for shoots to lock down the API server. So why not use it for the garden? I prepared a small demo. Hopefully my browser will let me share it. And also hopefully it is big enough. So if you can't read it, just scream. So the idea is here in the operator garden extension that we add this extension field in here of the ACL. And the operator then creates an extension object, so the ones that we know from seeds inside the garden namespace of the runtime cluster. And our ACL controller will then reconcile upon it and create the envoy filter to lock down access on the API server. But to do so, there was also a change in Gardener necessary to actually get the domain names of the virtual kube API server. So right now there's this little VIP branch in Gardener that adds the virtual cluster status into the Garden resource and populates this with the advertised addresses of the kube API server. So there's this new name added, which is at the moment virtual. It's up for discussion. But with this, the extension can read the actual domain of the virtual kube API server. And to see that in practice, we can look at the extensions. So we have this Garden ACL extension in the Garden namespace in our runtime cluster. And this gets reconciled. And what this creates is an envoy filter in the virtual garden Istio ingress namespace, which has this garden suffix. And in here, there's a lot of IP addresses. So first of all, we have the IP address that was actually specified by the user in the provider config of the extension on the garden. But we need some more IP addresses to actually allow, since we have components that might need to access the kube API server. So the second IP address sitter is here the node. This is the node sitter. So for example, Gardener node agents that might need to connect to the virtual API server can go via this IP address block. Then on here, there is the pod sitter. So for example, the Gardener resource manager in the runtime cluster or Gardener Gardener controller manager need to also connect to this. So we allow the pod sitter. And down here, we have some more IP addresses, which are the egress sitters of the shoots that are managed seeds. So as every gardenlet needs to connect to the virtual garden, we need to allow the gardenlets on the seeds to actually connect to the kube API server. And if you're lucky enough to use the managed seed implementation, we already know the IP addresses of the outgoing connections. So we have a watch on this as well, so that if you add a new managed seed and we add the egress sitter of the shoot into this allow list. And also, as previously, you can add your own IP addresses that you want to always allow, for example, jump hosts or something like that. And to show you that it works, I prepared a small demo, which is quite amazing. So on the top right, I have a shell that is set up to not use any proxy at all. So it's using my IP address. And I can tell you my IP address is not 1234. So if I'm now trying to access the API server, I won't get a response. And down here, where I'm connected to my jump host, I can still access the API server. So there is this allow listing in place. Yeah, so that's it from my side. And I will give to the next topic.
Yeah, really cool. Thanks, Lucas. Then next in the list, Stefan with replacing OpenVPN with WireGuard.
Yeah. Hi. Let me share my screen. So we can see it now. Me and Johannes picked up the topic which was already worked on a year ago together with Axel. So replacing OpenVPN in the VPN server components of Gartner with WireGuard, which is a much newer implementation, a small implementation of the VPN protocol or VPN network. Back then, a year ago, we managed to create a single shoot, which will then establish a working VPN between the two parties, between the seed and the shoot and the single shoot. But a lot of open topics were still there, like creating multiple shoots was not possible and so forth. And yeah, that's where we picked up and worked on 3.5 days of the whole hackathon, so it was quite intense. And no demo, sorry, I wasn't able to make it running on my laptop now, but should be enough to explain what we did here in the graphic. So what we basically did is we created a sidecar to the Istio Ingress load balancer, which opens a single port on 51820, which is the default port of WireGuard on UDP, because WireGuard is based on UDP. And in contrast to the OpenVPN implementation, where the distribution to the dedicated target shoot is done by an SNE field in the HTTP request of OpenVPN. This is not possible with UDP and WireGuard. So to multiplex the incoming WireGuard requests from the different shoots to the target VPN seed server running WireGuard, we have to place a sidecar, which we call WireGuard relay or multiplexer, to the Istio Ingress, which gets a config map where for every shoot the public key of the shoot is noted, and the IP address of the VPN seed server of that target shoot in the seed server. So, and with that, the multiplexer is able of analyzing the traffic, the incoming traffic, and forward the respective parties' traffic to each other. So with that, a working VPN connection between shoot B and the VPN seed server in the control plane namespace of shoot B is working. This VPN client or seed server components are implemented with WireGuard Go. It's a full Go implementation of the WireGuard protocol. And from the Gardenlet, they get a public-private key pair stored in the secret on both sides for the shoot and for the seed side. We actually didn't raise pull requests yet, but the required changes are listed here. So for the Gardener part, it's not so much changes required for the VPN2. We didn't create a VPN3 yet. For the VPN2, so including the WireGuard Go implementation and different handling of the secrets and so forth is shown in that comparison or that pull request or branch. And this WireGuard relay or multiplexer, we picked up already existing multiplexer and adapted it to suit our needs. It's called VPEX. There is one open topic because that's the GPL software, and Johannes would pick up this licensing issue because Gardener actually does not really allow or like GPL licensed software. But overall, it's in a working state. We can create multiple food clusters. We did some failover tests and performance tests. The later were not so satisfying. We actually got about half the speed than compared to the OpenVPN implementation, but that has to be redone once it's merged and done on new hardware. That's for now. Hope this was interesting. For me, it was a lot of fun, and especially to work with Johannes all week. Crazy stuff. Thanks.
Awesome. Thanks, Stefan. Then next up, Tim with making internal domain optional and mutable.
Yes. So after a bit of brainstorming on this topic area, we identified like 3 use cases or requirements, and we implemented the first one, and this is what I'm going to show today. If you want to check the other use cases, you can read through the issue. But basically, in some scenarios, you don't actually need an internal domain at all, and it might not even be desirable because internal domains are typically put into one public and shared DNS zone. And if you have like a private exposure of the API server, then it might not be desirable to put a DNS record pointing to some private IP or anything in a public DNS zone. But for now, the internal domain is required by Gardener, and you can't create shoots without an internal domain. So we worked on making this this optional so that you can create shoots without an internal domain, and also disable the internal domain of an existing shoot. So the idea here is that a new field in the shoot spec makes this optional. Potentially, it can only be set by operators and not by shoot owners. And disabling it after the fact would require a CA rotation because all the nodes, the workload, and so on need to reload their connection details, which is very similar to a CA rotation. So we just piggyback on the process. This is what I prepared in my demo setup. So I have a shoot which was created with an internal domain. And for the sake of speeding up the demo, I already disabled the internal domain and triggered the CA rotation. So you can see in the status there should be, the rotation in phase prepared. But as you can see on the seed side of things, we rolled all the control plane components and the machines and so on, but the internal DNS record is still there. So we keep it until the second phase of the CA rotation, meaning until the rotation has been completed. We can see that the internal domain still works by connecting to it via curl. I just get an unauthorized error, but it is still reachable. The important point is, however, that the workload and the kubelets don't connect to this anymore and use the external domain. You can see, for example, this pod now has the external domain in its Kubernetes service host environment variable. We can also check one of the machines and see the kubelets kubeconfig. It also includes the external domain. So now that all of our workload has been switched over to the external DNS record, we can now complete the credentials rotation and keep a watch on it. And as you can see, dropping the internal domain DNS record is one of the first things in the credentials rotation completion. But still, all the nodes and pods should be ready. Why can't I connect to this?
Because it's not HA?
True. Yeah, the control plane is not HA, and the etcd gets rolled another time during completion. You're right. Okay, let's give Kube API server a few seconds to get up again. So if you have an HA control plane, this obviously wouldn't incur a downtime, but in this case it does. Okay, there we go. So nodes are still there, and we should see updates on the kubelet heartbeats in the lease namespace. Let's see. Yeah, so kubelet is still renewing its heartbeat, meaning it keeps connecting to the new and preserved external DNS record. And that's basically what we did at the hackathon. We didn't implement the validation and the permission thingy, but we wanted to prove that this concept with piggybacking on the CA rotation is valid and doesn't incur any additional challenges. So the next steps would be to also take another look at the other use cases that we identified, like changing the external domain of a shoot, which would also require a CA rotation. In this case, we would not simply drop one of the DNS records, but keep the old one until the rotation is completed. And same goes for changing the internal domain of multiple shoots, meaning changing it in the seed specification. So that's what we have for now, and the Stackit team will continue working on this topic and open an enhancement proposal sometime in the next months. Yeah, that's it from my side.
Yeah, thanks, Tim. Great. All right. Next up is myself with experimenting with the shoot controller in self-hosted clusters. So what is this about? Let's go to the umbrella issue for get28, which is for the self-hosted shoots. There's a long list. So if you scroll down a little bit, we will come to the Garden ADM Connect section, and then this part here, which is about enabling all the needed controllers in the gardenlet for basically reconciling the shoot and doing the full life cycle, day 2 and updates and everything. As you can see, we have progressed quite a bit. Actually, all the controllers are done except for the main controller, the shoot controller. And this is actually, we always considered this quite complicated, because if you just take a glimpse at the code, so this is now the shoot controller in gardenlet, you can already see, if you scroll down, that there is this very complicated flow, which covers actually already multiple scenarios. So first of all, the normal shoot creation. Then we have also the restoration after a control plane migration here. We have support for workerless shoots and for hibernation. And if you go down, you see there are a lot of tasks. I don't know how many. Even if you try to visualize this, it will be a lot of crickle-crackle. So it's hard to read and hard to extend. And that's why we consider this controller very complicated to implement. And we wanted to try the hackathon to find an approach that is somewhat sustainable. Okay, so let me jump to the demo. I actually have set up here a local self-hosted shoot cluster with 2 nodes, 1 control plane nodes, 1 worker node. In the kube system namespace, we have the control plane running, etcd, API server, and so on. And we also have the shoot gardenlet, as we call it, running in kube system. So this gardenlet instance here is only responsible for the lifecycle of this self-hosted shoot. Then in the garden namespace, we have deployed Gardener operator, and with this also Gardener API server and the control plane. So that means we have a garden resource here, which is reconciled. And then we can take a look at the virtual cluster, and you see that here in the garden namespace, we have the self-hosted shoot. And in the last operation now, we see that the reconcile has succeeded. So this was actually the first thing that we wanted to achieve. This was simply not here before because the shoot controller was not enabled. So if we now trigger another reconciliation of the shoot and watch it, you can see that the shoot gardenlet is doing something here. And in the first step that we have implemented, it's basically just replicating the same steps that Garden ADM init has performed to set it up. So it's more or less reconciling the initial state, not yet really incorporating all the other tasks of the huge flow that I showed to you. But for now, this is the first step. And this already works. As you can see, it will go to 100% and everything is good. But this is just the initial POC, so to say. So what we basically want to do is to harmonize the Garden ADM init and Garden ADM bootstrap flow with the shoot reconciliation, because they are all kind of similar, at least partially. They have very similar steps. And in the hackathon, we tried to experiment with it. I will quickly demonstrate the concept. So we have adapted a first few set of flow tasks here, deploying namespaces, deploying the cloud provider credentials, CRDs, initialize secrets management, and so on. And what we have added is this function add group to the flow graph, where you can basically add a list of corresponding tasks that somehow belong together to the graph as one operation, so to say. And then we have in the bottom list functions like deploying the namespaces, which is creating such task group. And you see this can consist of multiple tasks. And here we are, for example, deploying the control plane namespace. And for self-hosted shoots, we are also reconciling the garden namespace. And this would basically be the idea, that we kind of make parts of the flow reusable in such task groups. And with that, hopefully make the flow more readable and more reusable as a whole, so that we can just use these functions to construct the needed steps for init and also Bootstrap. You can see this is just calling the same functions. And also in the shoot reconciliation, if we go down, we again have the same set of flow tasks here. Yeah, and with this approach, we would basically try to integrate also this new logic into the existing flow somehow. So yeah, that's basically it. Next steps are listed here. Basically evaluating this approach a bit more, because as you can see, we have just started with the first few things, but the list continues, of course. And if this proves to be worth implementing, then we would pursue this and do it also for the rest of the steps. Yeah, that's all, I guess. Okay, then next topic is Georgi, also for Web 28, implementing public CA bundle discovery mechanism.
Yes, I hope you can see my screen now. Yes, or?
Yes.
Okay, thank you. So the topic that me, Jeremy, and at later point Victor worked on was implementing a public CA bundle discovery mechanism for the GardenADM command. So what does that mean? For the kubeADM command that bootstraps worker nodes and nodes in general to Kubernetes clusters, the thing that we have to also provide when we want to connect a new worker node is the so-called CA bundle of the control plane. That is happening via the CA certificate flag that we use in the join command, and that can be also retrieved by running a token generate command. Currently, the GardenADM and the GardenADM join and the GardenADM command connect commands do not support only support this feature. So if we want to actually join a control plane node, a worker node to the control plane, or you want to join a shoot cluster to a virtual garden environment, we have to directly pass on the CA bundle of the API server of the control plane node or the virtual garden cluster. And the other option that is supported in the kubeADM is the so-called discovery CA cert hash mechanism, which pretty much just allows the user to pass the hash sum of the CA bundle that is located in the API server. So then it can actually get validated against the actual CA bundle. So what I mean by this, that if the user wants to actually validate at first that the control plane node or the virtual garden that they're talking to is the correct one, they can do that using this hash command. And what actually we had to do to implement this in the GardenADM command is at first to actually expose a new config map that is called cluster info, which contains the actual CA bundle of the API server as well as the bootstrap token. That way, the worker node that wants to join can actually use an unauthenticated connection to actually retrieve the config map and then validate the CA bundle of the API server against the hash that has passed in its command. And after that, it can actually send the certificate signing request so it can authenticate itself in front of the API server. Additionally, this is also what has to be done for the connect command. If we have to expose this config map in the virtual garden cluster as well. So what are the benefits from doing this approach? The first one is that we have a mechanism by which the worker node can actually verify that the API server that they're talking to is the correct one. And also after that, the shoot cluster can have a way to verify that the virtual garden that they want to connect to is a legitimate one. The second benefit that is being added here is that the hash sum, that the actual command gets a little bit more simpler to actually retrieve and get passed on, since we don't pass the entire base 64 encoded CA bundle of the API server. We just pass on the hash that is required to connect. And currently, I can demonstrate how that is done, but after a few rounds of discussions, internal as well as additional feedback that we have received, there is an added benefit from this approach, but it compared to the amount of code complexity and potential security risks that could be added with the exposure of this cluster config map unauthenticated exposure of the cluster the config map. The changes are not really that beneficial. So in order to actually demonstrate it, here is a local guide setup. Here I have already bootstrapped my machines with the GardenADM init command, and after that, from the control plane node, I can actually generate a token. The token create command with the print join, then gives me a GardenADM join command that I can run on the other worker nodes. So here, as you can see, we are now using the discovery token CA cert hash instead of the actual CA bundle of the API server. This command then I can actually copy and pass on to the worker node. And after running it, we can see that the actual worker node has been joined successfully to the Kubernetes cluster. So this is how it's working in the kubeadm join command. The GardenADM join command pretty much mimics that behavior one-to-one. So the actually more interesting part is how it's done for the GardenADM connect command. So the first step that we actually have to do is install Gardener or on the self-hosted shoot that we want to connect to the Gardener environment. So now we want to actually install the Gardenlet and the Gardener operator in the shoot. And if we actually want to see how this is done, we can pretty much it's a little bit slow, but now we can actually see that the Gardenlet is going to be installed soon enough in the shoot cluster. And after that, we can actually create the virtual garden cluster and then run the GardenADM command. So now we're currently installing the operator charts and the Gardenlet charts. Okay, we have installed it successfully. So now we're trying to install the Gardenlet. Can actually see as well that the GardenResource is getting prepared right now. This may take a minute. So to iterate what I tried to say earlier, we now have a possibility to actually just pass on the hash value of the CA bundle of the API server. That way, the worker node that wants to connect can first verify that the control plane or the virtual garden cluster that they're trying to connect to is actually the legitimate one. The bootstrap token also can get used in this direction, since before that, the bootstrap token was only able to verify that the worker node joining is the correct one. And if we actually, sorry about that, if we actually see the getting started locally guide, which is the scenario that I'm using, the next step that we have to do is so now I hope that actually is going to
I think the creation of the garden resource will take in a few more minutes, right? Because we also have to deploy API server and so on. Maybe we should skip this part in the interest of time, because it anyways works similar like the join thing that you showed.
Yeah, in all, what happens then is that the virtual garden cluster is getting made, and after that, the similar cluster info config map is getting injected into it and exposed via anonymous structured authentication that allows the self-hosted shoot to actually access it and do the same scenario that has been done for the join command. So yeah, that's pretty much it on my part. And if there are any questions, let me know.
Yeah, okay, cool. Thanks, Georgi. Then we have again Get28 and again Lucas, self-hosted shoot exposure in the Cilium extension.
Yes, thanks. So this topic is about running Cilium in self-hosted shoots. So first of all, the main goal was to actually get Cilium running in self-hosted shoots, because I think nobody yet tried to do so. And that came with a lot of things that were not working as we expected. So right now there is a new change in the Gardener that allows to use Cilium or run Cilium as part of your GINT setup. So I can show it to you how it will work. When we are running our make GINT up, or whatever you want to pronounce it, there is at the moment this new make variable that is the network provider. And by default, it will use just Calico. But if you want to create a self-hosted shoot that is using Cilium, as we might want to use for this self-hosted shoot exposure, we can do so by specifying this make variable. I did run that on the on my machine already. So we have a running GINT setup, which has the Garden ADM in it already run. So now what I want to do is to actually expose my API server of this self-hosted shoot. And to do so, we use this exposure, self-hosted self-hosted shoot exposure YAML. So it is not yet created by the Gardenlet. I think there's an open PR on the Gardener repository, but right now we have to create it on our own. And what we can see here, it is using the type Cilium. So right now I think there's only local implemented, which will do it in a similar way that we do it here. But there is also this provider config, which is part of the Cilium extension. So it at the moment has two sections, which is the announcement mode, which we will come at later. So and then there's also this IP pool sitters, which will be used to allocate an IP address for the API server. Cilium has the ability to provision services of type load balancer and announce the IP addresses either via L2 announcements. So this is using Gracious ARP, or there's also a mode that is able to use BGP, but this is not yet implemented during the hackathon because BGP is annoying. So this is quite similar to the way that Metal LB is doing it. So they also have this same idea that you can allocate services of type load balancer. But what this controller now does, so it's quite similar to the one that's implemented in provider local. It will create a service of type load balancer, which is called exposure self-hosted shoot. And this service is configured to use the load balancer class of IAO Cilium L2 announcer. This is necessary to tell Cilium, okay, pick this service of type load balancer up and create an IP address for it. So this IP address will be allocated by Cilium. It has a controller running, and this is the same one that is added in here. So the controller will do also an endpoint slice, which holds the IP addresses of the control planes. So this is the exposure self-hosted exposure IPv4, and this is the IP address of my control plane. So if I take a look here, this is the same IP address, and also the same IP address that was specified in the self-hosted shoot exposure. Additionally, there is this Cilium announcement policy, which tells Cilium which services to actually expose via L2 and Gracious ARP. So we match services that have this label attached to it, and this will be added to the service that is created for the self-hosted shoot exposure. Additionally, we have an IP pool resource for the self-hosted shoot exposure. And yeah, this has the same label selector, and it has the IP address that has to be allocated, or the block that should be allocated for this service. And yeah, so what Cilium does, it has a sort of leader election mechanism, same as Metal, LB, and for example, VRRP protocol, but it uses Kubernetes native approach, which is using leases. So there's a lease in the kube system namespace, which holds the machine that is currently announcing the service IP. So if, for example, we are in an HA setup and one of our machines go down, either expectedly or unexpectedly, Cilium on this node won't renew the lease, and therefore the kube controller manager will decide, okay, this is no longer valid. We have to drop the holder, and another healthy machine can then grab the holder of this lease and announce the IP address. And to show you that this works, we can spin up a container inside our client network. Because it is using L2, the announcements are only made inside the same L2 network. So since Docker networks are a slim or a flat L2 network, we can just run a container there to simulate a machine. And now if we are on this machine, we can access the API server via the IP address. Let me grab it. It's this one. So if we access this IP address, which is pure virtual, we can see that the response comes from the API server. And now we can also see inside our ARP table on this machine that we hold an entry for this IP address, so that this IP address translates to this MAC address. And this MAC address is the one that my control plane node that holds this lease is having on its ETH0 device. So this is the same MAC address as you can see here. If you have multiple devices, for example, Cilium by default will expose it on every Mac or on every device, but you can select this by yourself. So you can use a filter on your devices, which where you actually want to expose this IP address to, or this gracious ARP. Yeah, and with that we can basically access the API server from inside our network to have a more complex setup, or have your API server available throughout your data center. You might want to use BGP there, as this is more advanced instead of L2. Yes, and with this we are up with the demo, and we will continue to implement this and bring this into the Cilium extension. Thanks.
Cool.
Thanks, Lukas. Then next up, Marcel with running Garden and Seed in self-hosted shoots on managed infrastructure.
Yes, one more GAP 28 topic. You should see my screen. Yes. So in this topic, I worked together with Oliver, who unfortunately can't present today. And we tried to turn a self-hosted shoot in the managed infrastructure scenario into a seed and then run shoots on them. So just for context, self-hosted shoots with managed infrastructure means we use the Gardener tools to create the machine and network that then will run the self-hosted shoot. So basically what we were lucky because Raphael, just in time before the hackathon, created this PR which runs the operator and the seed in the unmanaged infrastructure case, and now we just in quotes had to port it to the managed infrastructure case. So without further ado, I have 4 Kubernetes clusters in my local setup running, and it is working. So maybe it's, I show the overview first. So what we have in the local setup with the managed infrastructure, we create a kind cluster that GardenADM Bootstrap will talk to create the machines. The machines in the local setup, of course, are pods. So we see the machine pods in the kind cluster. So in this setup, this on the very left is this kind cluster. And here we see the machine pods in the shoot garden root namespace. And then if one level deeper is the actual self-hosted shoot. And that after it has been turned into a seed and runs the shoot now has a couple of more namespaces and a bunch of Gardener components running. So first off, the kube system namespace is basically the control plane namespace of the self-hosted shoot. So that runs etcd, all the kube API stuff, but it also runs its own instance of a Gardenlet and a machine controller manager and a Gardener resource manager because it needs to be self-contained. But then, of course, after we install...
Ja, okay. Das ist gut. Das ist gut. Da kann ich dem Auto nämlich sagen, dass der Thomas das aufsetzt.
Thank you. Then in the garden namespace, we install the operator, and now this installs all of the garden components here. So again, if I go into my self-hosted shoot, we go into the garden cluster. There's a whole lot of stuff running here, and we have the garden resource, which is succeeded. And then once we turn this into a seed, we also start seeing the Gardenlet here as well. And we see the issue namespaces, for example, that are created for the seed. And then finally, I created a shoot, and that, of course, creates the shoot namespace, extends namespaces as expected. So just to prove the root shoot is the self-hosted shoot. Here we basically needed to fake the progress because this depends on what Raphael showed earlier, the Gardenlet reconciliation, but the actual local shoot got ready. Yeah, one major issue we faced was running Gardener in Docker and Docker and Docker and Docker. For this, we implemented a quick workaround that kind of fixes overlay FS stuff. But we're also working, Oliver also looked into running the machine pods as Docker containers, which worked, but also introduces a lot of complexity. So we'll likely go with a different approach. That would be to always run the machine pods in the outermost kind cluster. So instead of the machine pods running in this namespace, which runs in a Docker, we would run the machine pods of this shoot in the outermost kind cluster. And that's what I'm currently working on. And then I think after the previous work PR is merged, we will open a PR for the adjustments for the managed infrastructure scenario. All right. And I think I have the next topic as well.
Yep, just go ahead.
So this topic was worked on by Jeremy, who did the right thing and is on vacation this week. But I proposed it, so I have the honor to present it. So the idea was to make it possible for administrators to not use the admin access whenever they target a seed or a shoot. By default, currently, the garden login command kind of tries to always get the admin kubeconfig first, and if it succeeds, it uses it. But I wanted to have a flag to purposely not use the highest access level possible. And this already has an open PR that already had the first round of feedback and feedback implemented. So very quick progress here. And I'll quickly show this. So here I have a cluster with multiple seeds. And I created the garden config here with this new field kubeconfig access level defaults, which is a long name, but it shows you exactly what it is. So either for shoots or managed seeds, you can say if you want to use the auto access, which depends on whether you're operator or just user, or if you want to do admin or viewer kubeconfig. So now if I use GardenCuttle to target a seed, it shows me that it used the access level admin from my config here. But I can, and now to prove, I can get secrets. ta-da. But if I target the seed and say I want to be a viewer, that also works, but now I can no longer get secrets. Then in my config, I said whenever I access shoots, I want to be a viewer. So if I want to target this shoot now, I am viewer and I can again no longer get secrets. But if I target it with the admin flag, I can now get, oh, there's no namespace garden, but I can get secrets. And then one last thing, if I have a, so this worked, the seed I targeted was a managed seed. But if it's not a managed seed, then of course there is no such thing as dynamically created kubeconfigs. There's just a static kubeconfig. So if I now target this seed, which is a static seed, a non-managed seed, and I try to go to viewer permissions, I get an error message warning me that this access level function doesn't work here. And I just have this one access level that exists. Yeah, I think that's it.
Yeah, cool. Thanks for showing this. Then 4 more to go. Next up, Victor with staging the confineSpecUpdateRollout changes in annotations.
Hello. So basically me, Georgi, and Jeremy started working on this one. The gist of it is that there is this field that when enabled, spec changes of the shoot are applied and reconciled only during maintenance time window. And the problem with this is that, for example, if we do changes in the morning and maintenance is in the evening, the spec wouldn't really reflect the live state of the shoot. So for some users, this could be a problem. There are multiple approaches proposed for solving this issue. One of them is storing the changes. The shoot spec representing the live state of the shoots and the changes that a user wants to apply to be stored in annotations as patches, and then a logic to, in a way, do a merge of those patches. But for simplicity, because working with patches could be complicated, and there are some corner cases and some specifics, technical specifics, and maybe even problems with this approach, the final direction we chose to proceed is to have, instead of working with patches, to actually work with the whole spec resource. Let me show the demo. Currently, I have 2 shoots. The one is this unconfined, and the second one is normal shoot. Basically, nothing specific in them. Let me just, for example, so for example, this one has a maximum of 2 workers and the second one also. And I can show, just give me 1 sec. For example, when I do a patch of the unconfined, when raising from 2 to 10 the maximum number of workers, this passes and this starts reconciling. So basically we can see the workers are now 10 and the shoot starts reconciling. So, but this one is the confined. And with this feature that we created, basically patching to 10 will be blocked by an Ambition plugin. And then basically the message says the problem. Okay, patching is forbidden. Spec changes are not allowed when confineSpecUpdateRollout is enabled. Write your desired spec into a config map. For hackathon purposes, we use config map, but for production purposes, we can have a whole resource. For example, stage shoot update or something like that actually contains the spec. So yeah, let me show the config map. Okay, so this is the config map. Here I've written 20, for example, the desired states, right? So in the current state, let me check the current state, this one. So here we have 2, right? The config map. We can play around with it. So for example, one of my colleagues decided to have 20 workers. But for example, I say, okay, I don't want 20, I want 30, right? I'm saving, and we can check that nothing happens because those changes in the config map, that later on will be a resource with which will have proper validation. Here we can see, just a sec, 30, yeah, maximum 30. And so I will do a forced maintenance with this command, and we can see when doing the forced maintenance, this one, so we'll start reconciling, and the workers should be 30 as I showed updating from the config map. So basically that's the gist of it. When this feature, when enabled, admission plugin forbids any changes made by the user on the shoots with these fields, and if he wants to do changes to the spec, he has to use, for hackathon purposes, this config map, but for production purposes, there will be a specific resource for that. And this is the gist of the demo. Yeah.
Yeah. Thanks, Victor. Then next up, GardenState resource for automated garden cluster disaster recovery, presented by Luca.
Yeah, thank you very much. So Plamen and I had a look at implementing some resource we call GardenState, so that resources in the runtime cluster can be restored in case of disaster to restore the garden in a hopefully very automated fashion. So there's also a Gardener issue that I opened back then describing what's the problem currently. I mean, there's a documentation where it says back up all the secrets you need and the order in which to restore and manual steps required. And we now implemented a garden state that we encode in a secret. We decided against the CRD, but for a secret to be able to more easy encrypt in various runtime clusters. So to also demo this, I have already created some kind of disaster. I fired up a local setup. I then deleted my runtime cluster and I already recreated it to speed up this part a bit. So this you can see is empty. And all I would need to do is create this garden state and then scale up the operator. We can in a minute look in the garden state, but let's get this running so we can talk while the reconciliation is then going on. So what happens now maybe already is the garden operator has now a bootstrapper that detects that there is a secret for a garden state and there was no garden. So it restores the garden resource, patches the status. So maybe the credential rotation state, so that is all restored. And it also will restore all the secrets that we saved or persisted in that garden state secret. And after the bootstrapper is done, the ordinary garden reconciliation will then handle the restore. So while this is now going on, we can quickly look in this garden state resource, and I have decoded the state. And we see here, for example, we have the garden resource. We have maybe some extension state that I created. We have also secrets. that we require to be restored. And the Garden operator has already restored them. And then the restore process goes on. Yeah, we can already see that, for example, for this DNS record, I created some dummy state before it was restored already. And then soon the virtual garden will also continue to work, yeah, with all the encryption keys being restored, the certificates being restored. So my former Kubeconfig will continue to work here. And so we see this as an improvement to the prior process where really you had to restore the secrets manually, you had to scale down the Garden operator, patch the status manually. So we moved all of that logic, all of that handling in the Garden operator into code. And just by restoring the secret, we are then able to restore the garden. The contents of the secret is written after a successful garden reconciliation. So after every garden reconciliation, the secret is populated again with new certificates, whatever, what we need, new extension state, so that for a backup, this secret is then sufficient to be backed up instead of before Garden restores the status, the secrets themselves. So by now we can already see that this virtual garden access works again, and once the gardenlet would then restart, also the reconciliation of the seed could take place again. To what's up next with this implementation or with this topic. So there's been discussion, but I guess it's best to create a gap out of this to be able to discuss this then in a TSC meeting, maybe refine on the assumptions we made, on the implementation details we chose, and then hopefully after this is agreed on, we can go ahead with eventually opening a PR for this once this has been refined. And I think that's it.
Awesome. Thanks, Luca. Then we have separately encrypting the etcd backups presented by Matthias.
Hello, everybody. Rada, Garrett, and Mia were working on encrypting the etcd backups. We decided to not re-encrypt the backups that were already made, but persisting the whole keyring. That means all keys that were used in the past for encrypting backups into a file in the backup that is encrypted with the latest keyring. This makes immutability of backups possible, and also serves the purpose that you can restore any backup that was done. You can activate backup encryption via in the shoot spec as shown here. At the moment, only the AES GCM provider is implemented. When annotating, when changing the shoot spec, Gardener will create an encryption key and also an encryption configuration that is passed to the etcd. You can rotate the encryption key via annotating the shoot with the rotate etcd encryption key annotation. During annotation, two keys are created and both are passed in the encryption configuration to the etcd backup restore container. After rotation, only after two rotations of the shoot, only the new key is persisted in the encryption configuration. And we tested the restore via deleting the etcd just and threw away the PVC and PV. And we saw that a canary secret is retained during the whole operation. Here's a view of the backup bucket. First, the shoot was unencrypted. That's the first snapshot. And after that, it gets encrypted. The keyring is persisted in the backup bucket. And each of these files contain the key that it was encrypted with it. You can see it just by looking at the files themselves. And the keyring is encrypted with the latest key, as you can see here. We also provided a decryption utility because operations where you can get the snapshot back by providing the encryption secret out of your out of the Garden runtime cluster. And you see that it's basically available now. Open topics we see is we have to clean up the code. We had to touch the 3 repositories, Gardener, etcd Druid, and etcd Backup Restore. We did not test yet the hibernation and migration steps, but I suppose they would work because it's all pretty straightforward. The integration to the new shoot spec should be validated, that also the encryption secrets and encryption config are migrated, and it should also be possible to implement it in the virtual garden backup, but this was not yet tested. Up to the next one.
Thanks, Matthias. Then we have only one more final topic for today, which is reducing the secret watch pressure by splitting managed resource data, presented by Plum.
Hello, sorry, my Teams froze for a second. So let me share my screen. Okay, maybe increase the size a little bit. So I had little time to work on this topic during the hackathon. Basically, the gist of it is that we create a ton of secrets for managed resources where the data for managed resources is kept. And consequently, so these secrets are, of course, immutable so that there is no pressures on the kubelet and other Kubernetes-related controllers. However, we might have some controllers on our own that we install that potentially watch secrets, and this could cause their caches for secrets to get to a relatively large size. So the idea was to split now this data used by managed resources so that only secrets that are used are stored in such secret references, and other resources such as deployments, etc., are stored in a new CRD. Of course, this one other idea was that this split should happen dynamically, so we have a couple of utility functions that are used across our code to create such managed resources and secrets. So those should be kind of aware of the resources that they are deploying, automatically detect if they are deploying, they should deploy a secret or not, and then place those in the corresponding secret reference or managed resource or CRD reference. And of course, we should also pursue this only if it actually makes sense. Or if we would gain benefit by reducing the number of secrets. So I did some small measurements on some of our clusters. So for particularly high loaded seeds, for instance, more than 100 choices, you can see here from the table, the secrets, actually the secrets that are for managed resources end up being around 1 megabyte per shoot for these seeds. So generally, mostly the secrets that are in the shoot control planes are contributing to this, of course, because there are many control planes. And then the ones in the Garden namespace or extension namespace, they don't actually contribute that much. So actually, and one more thing here that's worth noting is that secrets for managed resources contribute for more than half of the data stored in secrets in our clusters. So generally, reducing them could have some improvement. However, I then checked which controllers actually still enable caches for secrets. And I found out that all our provider extensions and additionally other extensions like registry cache, RSFLCRELP, ShootDNS service, and so on, actually disable caches for secrets, which, the reason for this was exactly the ones used by managed resources. So what this leaves is potentially extensions like cert management and external DNS management, not extensions, but controllers, and machine controller manager, and so on. However, those still have to be double checked to see what exactly the impact is of secrets on them. But so far it seems like at least controllers installed by Gardener aren't really that impacted. And then what I wanted to check is actually how hard the implementation would be to maybe have at least some idea whether it's really worth to do it. So what I managed to do during the hackathon quickly was create a new CRD, call it Managed Resource Data, that has similar schema as secrets. This could be discussed later on if we decide to actually proceed with this issue. And then I extended the managed resource to have now secret refs and data refs field to include both of those. So this managed resource data, there was no need to make it unique, maybe similar to what we do for secrets, because we make the secrets name unique because they are immutable. But I think for the CRD, this would probably not be necessary. And then for the actual code changes, what I did was change some stuff in the registry.go utility that we use to create managed resource data, so that it now dynamically splits data into two keys, where data YAML broadly is, because it compresses data with broadly. So one of the keys is used to contain only secret resources data. I kept the key here for backwards compatibility. And then for non-secrets, they are now compressed in this new key code with the plain prefix. Similar to create update logic in ManagedResources.go, I now use this split to either determine whether something has to go in a secret or a data ref. And in the end, generally the managed resource data was 105, and the remaining secrets were 26. For a local cluster, which I guess is quite a substantial decrease of secrets. And I can show it real quickly in my cluster that I've prepared here. So this is a cluster before my changes. As you can see, there are a lot of managed resource secrets deployed here. There are a bit more because I only listed the ones with the managed resource prefix, but I think there are only a little bit more that do not have this prefix, but this does not matter to show how much we currently have. So all in all, there are 109 such secrets with the managed resource prefix. And then if I actually do this now for the, after I have deployed my changes, you can see that there's only 26, as I showed in the dashboard, which is more than a 5-time decrease of secrets. And then to also show what it looks like. So for instance, I can now get this managed resource Plutono secret, which if I decode, it only contains secret information for the Plutono deployment. So I'm not really sure what this is here, but if it was a secret that had to be deployed, it's part of this managed resource secret. And then here is the TLS certificate type data, and there is nothing else. And then if I get the corresponding managed resource data here and decode it, you can see that it actually contains everything else. And the change is currently backwards compatible, so I don't have to recreate anything during deployment. Yeah, the shoot reconciliation succeed and Garden reconciliation succeed and so on. And then what's left would be to do a more detailed analysis of the impact of this reduction of secrets. Yeah, as I mentioned, there are some controllers that still have to be checked to decide whether this is worth it or not. And then, of course, this splitting heuristic, the current approach is kind of hacky, as I had to do it really quickly. But maybe in the future, we could use a special interface that, yeah, is better used to split the data and enforces actually this data split to utility functions. And that's all, I think, for this issue.
Yep. Awesome. Thanks, Plan, presenting as the last one. We finally made it quite right. Thanks, everybody, for joining this meeting and staying so long. This was a lot of content to digest. Yeah. Thanks also to the folks from Excellent for, again, organizing the logistics of the meeting, of the hackathon, and Toby and Mark for organizing the topic voting and topic assignments. And yeah, generally, thanks everybody for joining and coming to this crazy week. Okay, then we close the meeting for today and continue next week with the regular review meeting content and the 1.142 release. Have a nice time. Until then, bye-bye.
Bye-bye.
Thank you. Bye-bye.
Bye-bye.